Good morning everyone and welcome to this video. Today I'm going to show how to invoke and how to use the C# compiler with Roslyn and .NET Core to perform some code generation on Windows, Linux and Mac using Visual Studio Code as an IDE. Before we go on with the video, you need to set up some prerequisites. More specifically, you will certainly need a Windows PC. Optionally, a Ubuntu installation based on version 16.04. This can be a physical installation or a virtual machine, as you like. Optionally, a Mac with VS Code. Certainly, you need .NET Core SDK. I'm currently using version 1 Preview 4 build 4233. Here you can see the URL of the release notes for this build. Notice that Microsoft is releasing previews of .NET Core very frequently, but you need at least a version that supports the MS Build solution project system. So what you will see in this video is not based on project.json, which was supported in the first version of .NET Core. Here you will see CS.Proj files and the MS Build solution project system. Finally, you need to download and install Visual Studio Code from code.visualstudio.com. Make sure you select the appropriate download, especially if you are installing VS Code on Ubuntu. There is a specific download. Okay, about installing .NET Core, a good idea is following the instructions described in the release note page. Here you can see something on my desktop, but you will need to open the URL in your web browser. More specifically for Windows and Mac, there are the appropriate setup packages, while on Ubuntu you will need to perform some manual steps. By the way, here you find all the instructions you actually need. Okay, so what we are going to do, I'm going to show a sample code that I already prepared and that we will rebuild as we go on with the video. So this is a C# console application based on .NET Core. What the application does is simply writing some C# code. This code is stored inside a string, so this is text. Then you get a syntax-free object through the C# compiler. The C# compiler is invoked through the Microsoft.codeanalysis.C# library, and here you have an object called syntax factory, which has a method called parse syntax-free that generates an object of type syntax-free that represents the way the compiler sees our source code and interprets the source code and provides information about the source code and generates the source code into something .NET can execute. The code next invokes this kind of method called print diagnostics. This method is simply responsible for finding any diagnostic information in the source code. For example, with the get diagnostic method, we can see if there are any code issues, such as syntax errors or any other kind of errors, warnings, and information messages in the code. The code in the application then prints any message for any diagnostic, and it also prints the position of the code issue in the source text. Going on, the code uses an object called C# compilation and a method called create to generate an assembly. With this method, I'm going to create a C# compilation object with some options. For example, I'm specifying the output kind, in this case a DLL library, and I am adding one reference in particular. More specifically, I'm going to add a metadata reference from a file that defines the type object. So in this case, I'm going to basically add a reference to the system namespace. Then I'll be getting the location for the assembly, and finally I'm going to add the syntax tree into the assembly. The next step is creating a path name for the output assembly, and notice that this path.combine method will be exactly the same on every supported platform. And in the end, I'm going to call the emit method from the C# compilation object. This will physically generate the DLL library. We are going to load the assembly from disk, and we are going to use reflection to invoke the class that is defined inside our syntax tree, and then we are going to call a method called calculate circle area. What this method basically does is calculating the area of a circle based on some hard-coded values. Okay, let me fix a couple of issues here. Now let's run this sample application. Okay, so a couple of things you will see here. The text you see here in the debug console is how the compiler is receiving our source text in the form of a syntax tree object. And here you can see how we have been able to invoke the result of our compiled code from the output assembly. Now let's see what happens if I introduce a couple of code issues in the source text. For example, I can remove some symbols. Alright, let's run again. So the interesting thing is that Roslyn can still create a syntax tree from a source code that contains some code issues. And here we are getting diagnostic messages from the source code. So the compiler is reporting some code issues from the source code that is stored inside our string. For example, I have a couple of code issues with the text messages and the position in the source code. So for example, at line 9 and line 13, I have two code issues. Notice that this is the most basic form of code generation you can perform with Roslyn, but you can do very complex code generation, even though actually not all the Roslyn libraries have been completely ported to .NET Core. But the library you actually need to perform this is currently supported on Windows, Linux, and Mac. And the package you need is this one, microsoft.codeanalysis.c#. Now let's see how to recreate this example on three different platforms. So on Windows I have a command prompt here, and I'm inside a folder. I'm going to create a new subfolder that I called, for example, Roslyn sample. I enter this folder, and then I simply use the .NET command line interface to generate a new application by writing .NET new. This simply generates a new C# console application based on .NET Core. In VS Code, I will open the new folder, which is located under temp and Roslyn sample. All right. If this is the first time you are running Visual Studio Code against a C# application, the IDE will suggest you to download a couple of extensions, such as the C# extension and the .NET Core debugger. Now let's take a look at the project file. As you can see, with .NET Core, all the NuGet packages references are included in the CS.project file. So let's go back to my original project, and let's take a couple of NuGet packages that we need to download and install. Alright. Microsoft.codeanalysis.c# is the library that provides you an option to invoke the C# compiler. You need at least version 2.0.0 RC2. The other package is called system.runtime.loader, and you need version 4.3.0. and allows you to perform reflection against an external assembly. Okay, let's save. As per today, Visual Studio Code has not a perfect integration with the .NET Core in terms of MS Build solution. So the .NET Core command for restoring NuGet packages doesn't work very well. So let's go back to the command line and let's type .NET restore. Alright, so we have been able to restoring the required NuGet packages. We can save. This is actually what you need. You can then go back to your C# code and then you can write all the code you want to perform code generation with Roslyn. Notice that VS Code will ask you to your permission to add some required assets. So click yes, and that's okay. So what you can do at this point is simply copy and paste all the code you have seen before. Will come exactly to this result. Of course, you are totally free to change the code. Just to demonstrate that I'm telling the truth, as you can see, I can add a using directive on the Microsoft.codeanalysis.C# namespace, and then I can invoke the C# compiler through syntax factory.parse syntax tree and then passing a string. No worries if you see a squiggle, it will disappear when you compile the code. When you go to the debug panel, you will see that the debug configuration for .NET Core has already been set up by VS Code for you. Okay, so at this point you can simply go back to the original sample project and perform your code generation using Roslyn with VS Code and .NET Core. Now let's go to see how the same thing can be done on different operating systems, and I will start with a Mac. I'm on my Mac here, and I'm on a TeamViewer connection for this purpose. So what I'm going to do is creating a new folder. I will give a name such as, for example, Roslyn sample, like we did before. I'm going to open a terminal on this folder, and I will still use the .NET command line, so I can write .NET new. Okay, so in this folder you will see the new console application written in C# and based on .NET Core and the MS Build project system. Okay, so at this point we can open the new folder with VS Code. Okay, here I have a new window, and we can perform the same steps we did before. So I have of course the sample project ready to be used, and I can copy and paste the NuGet package references I need. Then I go to the other window. Okay, let me resize the VS Code window for this purpose. I can simply paste the NuGet package references. Of course, I need to save. Alright. Then in the terminal I will still type .NET restore. The first time you will use the .NET command line on a Mac as well as on a Linux system, the .NET Core SDK will also download additional files it needs to work. Okay, so everything has been downloaded. Then I go to my C# code, and then I can invoke the Microsoft dot code analysis dot C# namespace, and then I can be able to invoke the C# compiler and Roslyn on a Mac. I click yes here for the project assets, and now I go back to my ready-to-use sample project. You can see it's exactly the same source code you saw on a Windows version. If I now run this source code, great. So the C# compiler based on Roslyn is recognizing the syntax tree, and it is detecting code issues as we actually expected. So this is the case in which we have intentionally caused some code issues, but we can also fix this code. Let's add the missing symbols. All right, now let's run again. Okay, great. A DLL library was correctly generated, and the sample application has been able to load the DLL library and to invoke objects and methods in the library using reflection. We have been writing C# code, we have been invoking the C# compiler with Roslyn on a Mac. Now the final demonstration based on Ubuntu. So the final demo is on Ubuntu, and what you will see now actually works on any of the Linux distribution in the same way. Let's create a new folder that I call Roslyn sample. Then with the terminal I can generate a new .NET Core application based on C#, writing .NET new. And as you can see, I have the program.cs file and the csproj file. I will do the same things I have done before in VS Code. So I can open the folder. All right. File, open folder, Roslyn sample, OK. I will need to copy and paste the required NuGet package references. OK. Let me save. Then I go back to the terminal, and then I type .NET restore. After a few seconds, the .NET SDK will complete downloading the required NuGet packages, and then I go back to my sample project, and at this point, OK, I will still be able to write the same code that allows me to invoke the C# compiler, this time on a Linux machine. The same sample project is here. Exactly the same source code. I can go and run the application. So I placed a breakpoint here just for demonstration purposes and to demonstrate that you can get all the information the compiler is able to provide on the syntax tree. So you can use a breakpoint and investigate the local variable, in this case, that contains the syntax tree generated by the compiler starting from source text. If I go on with the execution, I can see how the syntax tree has been correctly generated and how my code has been able to invoke a DLL library and to retrieve objects and members that have been invoked to perform a math calculation. This has been done on Linux, so we have been able to write C# code and invoke the C# compiler and perform Roslyn code generation on a Linux machine. So a couple of final considerations. Of course, what we have done with Visual Studio Code can be done with Visual Studio 2017 on a Windows machine if you install the .NET Core components from the Visual Studio installer. It can be done with Visual Studio for Mac on a Mac machine, not just Visual Studio Code. .NET Core generates, let me show what it does, generates a bin folder with a debug configuration, and as you can see, it generates the DLL library that you can share or publish or use in any other .NET Core application. So in the next video I'm going to show how to reach the same objective on a Mac using Visual Studio for Mac instead of Visual Studio Code. A very final consideration is that today you can use the C# compiler and the Microsoft Code Analysis libraries. You cannot use the Microsoft Code Analysis workspaces libraries, which haven't been ported to .NET Core yet, but maybe you will be able to do it in a near future. Thank you for watching this video.